In this session, we will analyze the results of small UAV. Let's begin with the result analysis. For that, go to Simulation Runs, click on Run and then on Post-Process Results. In Parts Color, select Pressure, hide the domain, the pressure counter plot of the small UAV is as shown on the slide. The airflow over the upper surface of the UAV moves with high velocity, creating low pressure. Due to this low pressure, suction force is generated near the leading edge of the wing, which increases the airflow over the upper surface of the UAV and also increases the lift coefficient. Whereas the air flowing at the lower surface of the UAV moves with low velocity, creating high pressure, which contributes to the lift generation. Let's inspect the pressure value at the upper and lower surface of the UAV. For that, select Inspect Point and click at any point on the surface of the UAV. So here at the lower surface, at this point, the pressure is 9.775 e power 4 Pascal. You can select any random point. So here the value is 9.775, 9.776 e power 4 Pascal. So let's see what is the pressure at the upper surface of the UAV. So for that, click at any point on the upper surface. So here the pressure is less, that is 9.774 e power 4 is the pressure here, and here it's 9.772 e power 4. So at the upper surface of the UAV, the pressure is less. At this point, the pressure is 9.771 e power 4 Pascal. So the pressure is less at the upper surface of the UAV and the pressure is high at the lower surface of the UAV. Next, let us analyze the velocity magnitude counter plot. For that, go to cutting plane. Hide the domain. So I'll cut the UAV at this position along Z orientation. Disable parts color. This is the velocity magnitude counter plot of the small UAV. As we analyzed from the pressure counter plot of UAV, the pressure is low on the upper surface compared to the lower surface of the UAV. As we know, according to Bernoulli's principle, as pressure decreases, velocity increases and vice versa. Therefore, velocity magnitude will be high at the upper surface compared to the lower surface of the UAV. You can also inspect the pressure value at the upper and lower surface of the UAV. So at the upper surface, the velocity magnitude at this random point is 11.23. Let's see at the lower surface. At the lower surface, as you can see, the velocity magnitude is less, that is 10.45. Next, to analyze the flow over the surface of the UAV, add particle trace. Disable cutting plane. Click here and adjust the vertical and horizontal seats, spacing and size of the streamlines. I'll keep it 40. Hide the domain. In parts color, select solid color. You can adjust the spacing and size here. Let's animate this streamlines. For that, go to animation. I'll select the particle trace. I'll increase the animation speed and play. Next, to view the values of lift force, drag force, lift coefficient and drag coefficient, go to force plot, forces and movements. Here pressure force X is the drag force and pressure force Y is the lift force. First we shall see the drag force value. The pressure force X or drag force is 3.42827 Newton and the lift force is 30.80834 Newton. Next, for the lift and drag coefficient values, go to force coefficient plot. Click on forces and movement coefficients. You shall see what is lift coefficient. It's 0.176232 and the drag coefficient value is 0.024652266. If you divide the values of lift and drag coefficient, you will get lift to drag ratio of the small UAV, that is 7.162. This completes the analysis of small UAV. Here I will end up this session. Thank you.